So in all of the previous squeeze theorem videos, we worked examples that involved just bounding one function. So we bounded one function that was contained within the function we wanted to find a limit of. Then we multiplied or divided that function by another one and multiplied or divided the bounding functions also. The functions that bounded our function of interest by that same function. But here we're going to actually be bounding two functions in finding a limit. And the limit we're going to be interested in finding is the limit as x approaches infinity of e to the minus x plus cosine cubed of x divided by x squared plus 5. So let's look at e to the minus x and cosine cubed of x separately. So just draw some axes here, and we'll say this is positive 1. E to the minus x is going to look something like this, right? So as x approaches infinity, e to the minus x is going to approach 0. What about cosine cubed of x? Well, cosine cubed of x, cosine of x always ranges between 0 and or negative 1 and 1, right? So cosine of x always ranges between negative 1 and 1. So cosine cubed of x is also going to have to range between negative 1 and 1 or negative 1 and 1, because negative 1 cubed, so cosine cubed of x be ranging between negative 1 and 1, because negative 1 cubed is negative 1 and 1 cubed is positive 1. So cosine cubed of x ranges between negative 1 and positive 1. So we looked at the limit as x approaches infinity of e to the negative x. When we're considering this limit as x approaches infinity of this function here, we can really restrict ourselves to positive numbers. So for positive numbers including 0, e to the minus x is going to be e to the minus x is going to have a high of 1 at x equal to 0, but as x approaches infinity, it'll approach 0 but never really be 0. That's why we have a less than sign rather than a less than or equal to sign. So what's the deal with this sum here? E to the minus x plus cosine cubed of x. Well, cosine cubed of x at the low end is negative 1, and e to the minus x at the low end approaches 0. So negative 1 plus 0 is negative 1. That is the lower bound for this sum here. What about the upper bound? Well, the upper bound on e to the minus x is 1. Remember, when we're restricting ourselves to positive values of x, but will also include 0. And the upper bound for cosine cubed of x is 1. So the upper bound for the sum is 2. Now remember, as in all squeeze theorem problems, we're trying to make this function here look like our original function. So to do that, we'll have to divide it by x squared plus 5. But in this inequality, we're going to have to divide everything by x squared plus 5, and because we're looking at the limit as x approaches infinity. We're only really concerned with positive numbers, so x squared plus 5 will be positive. We'll be dividing by a positive number, so the direction of the inequality remains the same. And now we'll be looking at the limits as x approaches infinity of these two outside functions. So first, the limit as x approaches infinity of negative 1 over x squared plus 5. Well, as x gets really big, this x squared plus 5 term gets really big. Negative 1 divided by that's going to be a number really close to 0. And in the limit as x approaches infinity, this limit is 0. Should be a 0 here. Now what about the limit as x approaches infinity of this function? So the limit as x approaches infinity of 2 over x squared plus 5. Well, as x gets really big, x squared plus 5 gets really big. 2 divided by a very large number is a very small number, and as that number becomes infinitely large, 2 divided by the number gets very close to 0. So this limit is also 0. So by the squeeze theorem, the function in the middle, the limit as x tends to 0, the function in the middle of these two functions is also 0. So the limit as x approaches infinity of e to the minus x plus cosine cubed of x over x squared plus 5 is 0 by the squeeze theorem. So all we did here in this example was we bounded both this e to the minus x function and this cosine cubed of x function. Then we took the sum of their boundaries to generate this inequality here. We divided every portion of the inequality by x squared plus 5, and because we were concerned with the limit as x approaches infinity, this entailed division by positive numbers, so we did not have to change the directions of the inequality signs. Took the limits of these outside functions, they equaled 0, so by the squeeze theorem the limit of this inside function is 0.